Welcome to Data Forward, the podcast that keeps you ahead in the fast-evolving world of enterprise AI and data management. We bring you expert insights, actionable strategies, and the latest trends to help you stay on top. Ready to shape the future of data? Let's Data Forward.
Hi, and welcome to another episode of Data Forward. I'm Joe Murphy, a principal architect in Acceldata's field engineering team. And today we're going to be talking about frameworks then and now, how to build reliable data systems that really stand the test of time. And I'm thrilled to have with me Jay Sivasamy from Workday. I'm thrilled to have him with me because he has a ton of experience in building scalable frameworks that help understand complex data systems and then turn those into reliable, measurable results. Jay, thanks for joining us today. And why don't you share a little bit about your background?
Sure. Thank you for having me, Joe. And yeah, this is a very exciting topic where data reliability, which I've been a part of, since my beginning, right? I started my day job almost like more than 2 decades back, and it has always been the crux of any data system that we build. Irrespective of what it was then, it used to be data warehouse with facts and dimensions, and it was used for simple or complex reporting. Then, dashboards evolved, and even today, with AI and ML and models, which are trained with trillions of parameters. It's like 5 trillion, 4 trillion as we speak. So data reliability has been the front, center and crux of all these data systems that we rely on, and increasingly towards automation and a near human experience as we move towards ML and AI. So I'm really excited to talk about it. And of course, I really look forward to bringing in value to the listeners as well. And thank you for having me again.
Well, thank you. So why don't we get started by having you define what makes a data system reliable and some examples of how you've done that over the course of your career.
Absolutely. So there's a line between data quality and data reliability, right? If you take a manufacturing line for cars, for example, so all the cars, you certify, you look at their quality. Hey, does it fit for hitting the road and so on? That's data quality, equivalent to data quality, right? You check, certify, deliver the car. So that's where the certification stops, right? It's ready to hit the road. You go to the DMV, you book it, you register it. However, reliability comes in after, right? Which car stays at the same performance, at the same trust that, hey, I can take this car, go for the next, drive for the next 500 miles, right? So that is proven over a period of time. That's how I would also relate it to the data terms as well, right? Is my data reliable? Of course, we all certify the data, right? There is QA done. I see all the values, all the metrics, and all the attributes as expected today. It hits production, right? What happens after 6 months, what happens after 1 year, and what happens after 3 years. So that is key to not just the technology folks, but the business folks. That's where the very critical aspect called trust comes into picture, right? And we have had numerous examples of where trust was broken because of something fading over a period of time. For example, one of the most recent failures in the news was the Deloitte and the Australian government incident, which was in the news, publicly available, and so on, where trust took a hit. So that trust taking a hit, why I'm emphasizing on that is because it relates to everything else. There's a financial impact, there's a people impact, there's a market impact, and so on. So data reliability, given all these factors, how it impacts business, it is not just a technology problem. It has evolved into a business and an everyday problem as we go.
I love the analogy to manufacturing. I've often thought about that in terms of data systems, because if you think about manufacturers, they look at the quality of their product, but they also look at the yield of the product. They look at specs of data, equipment coming in, data coming in. They look at how the manufacturing floor is flowing, how that data pipeline, all to get to that trust of that reliable product at the end, right? So I think, as you brought out very clearly, that analogy of how we deal with manufacturing, modern manufacturing lines, is really akin to how we should be dealing with modern data manufacturing lines, data pipelines, all lining up to the new world that we're in. So, given that, I guess the question I'd ask is, how did you approach building and governing these systems, say, 4 or 5 years ago? And then thinking about how things have changed, even in the last year with the advent of AI and that. How did you approach building reliable frameworks for this, and how are you approaching it now?
So I would still take it even further down, right? Uh, 10 years back, then 5 years back, and where are we today, right? Till 10 years back, I'm talking about pre-big data world, pre Hadoop and MapReduce, where it used to be data warehouses with dimensions and facts and so on. And the analytical space was also coming up, right? The tools were introduced, like MicroStrategy, business objects, and so on and so forth, which leveraged the data warehouse. At that point in time, there were ETL pipelines which had been performing this data transformation, which was kind of not as complex as it is today.
Mm-hmm.
And at that point in time, there were simpler frameworks. So I still remember, we used to have, post every pipeline batch or every pipeline, there used to be a script which runs in production, looking at the numbers, nulls, which we call as baseline checks, right? Hey, these are the counts. These are the number of nulls to validate the completeness and how accurate we are from a numerical standpoint, like summations and so on. So that was the primitive state of the data reliability frameworks. And moving on to a little bit more evolved state where Hadoop and MapReduce and the big data systems came into existence, where the compute is distributed and the span of data increased. So now we are getting into unstructured data. There's a lot of unstructured data, which is termed as schema and read. Rather than, we build database systems which are very well modeled, structured. We got into the space where we got blobs, right? There is no defined structures to it. At that point in time, Joe, there are two things which happened. One, the frameworks become even more critical because on one hand, we needed to prove the data is reliable with the numbers and checks and balances and so on, auditability. And on the other hand, the complexity increased where there is unstructured data, there is schema and read. The two things which happened are we needed the frameworks to evolve to cope up with these changes, both from a compute and from a structured and the unstructured standpoint.
Right.
And even more important is the second aspect, where the data quality and the data reliability checks got decentralized. So now that we are looking at unstructured data, a lot of garbage coming in. There's a lot of sources of data which are like from IoTs, like Internet of Things, throwing in petabytes of data, not even terabytes, petabytes of data. So the developers, not just the QA folks, right? The developers had also need to pitch in. So that's what I term as like decentralized, where the developers and the analysts working on the data are also responsible to have data cleansing in place, checks in place. Every time a pipeline runs, I want to make sure I'm able to read this data, I'm able to segregate them, distribute it across that computing. So this is, I would say, to your question, around 5 to 6 years ago, right? And we thought we have figured everything out. And then came the cloud. So with cloud, the complexity also increased because now we have really extended systems and split by regions. split by geographies, and distributed teams across the globe started accessing the cloud data, and that kind of forced the frameworks to evolve. And the frameworks evolution really bridged the gap between what is expected, because the expectations have always been a constant, right? I need auditability, I need compliance, my data governance team needs to have control and visibility into what's coming in and what am I certifying for the business to consume. So this has been a constant. On the other hand, the scale is, blowing, right? That is, explosion of scale.
Complexity, right? The complexity as well.
Complexity.
Loaded.
Yes.
It's not just the scale; it's all the different types. With that semantic of the governance team trying to now control not just the warehouse 10 years ago with a set number of tables and dimensions to deal with, but now the lake, lots of unstructured data, lots of different technologies facing with them, right? So that building that framework, right, is been the challenge that many have faced, right?
Yeah. And Joe, one thing I would like to highlight is it is not just the complexity and the scale which became a challenge, but there were capabilities which came along, which kind of helped to improve these frameworks as well, right?
Good point.
Yeah. So initially, we used to have these frameworks built out of a database, and we had set number of tools to execute these frameworks and maintain these frameworks. And as we evolved, as we got in cloud and data observability tools, data reliability tools, Acceldata, for example, as well, right? So we had automation also catching up, so that the frameworks are not just standing on their own. So we have tools like Acceldata or observability tools, providing that information, checks and balances in real time and near real time. Yeah, that's one of the aspects which changed as well, right? We are trying to go as near real time or real time as possible. So the tools aiding these operations when it comes to data pipeline execution, data reliability checks, the baseline validations have pretty much been covered in an automated fashion. Then comes in the business validations, right? And that's how I see the evolution from big data to cloud with multiple. Some of the organizations even have multiple cloud platforms. So the API capabilities that we brought in, and the data reliability tools that we have with the frameworks which are homegrown, or frameworks which were adopted from outsourced or open source organizations, that were really helpful.
So a question for you then, and in my role, I end up talking to a lot of companies, and one challenge they come up to me with is they'll have sort of the governance business guidelines, a governance framework, but then they struggle to make it operational. So on this complex landscape, so that they have the trust, right? It's sort of bridging the gap from the old days, well, I just ran a script, to I have this complex landscape. I know what I should be doing. But have you seen that problem in your landscape, and how have you attacked it?
So we kind of attacked it both from a functional and a technology standpoint, right? A techno-functional standpoint. So technology can do marvels, but unless it kind of meets what governance and business and auditors need, kind of it loses its charm and over a period of time. So when I say it's a techno-functional approach, is one of the frameworks that we worked on like earlier in the days. It is not just looks for data reliability in accuracy, freshness, and so on. We also had to exactly to that question, right? If a governance data owner or a data product owner comes to me and looks for, how do I ensure bad data does not reach the business, or bad data does not reach the decision makers? So the pipelines and the frameworks were integrated to make sure the checks and balances are executed as the pipeline progresses.
Exactly.
Right. And it is technology agnostic, right? So we in the last 10 minutes, we did not touch upon any one particular technology or any one particular method, because these are all, the frameworks are meant to be agnostic of the technology. So we had these checks, and some of them are threshold based. You know what? If it does not meet 75% of accuracy or completeness, we'll not even move forward with the next step or the next pipeline, right? So that the decision makers don't get the data itself, right? So it stops right there. So that's where the technical teams engage with the data governance teams to fix the loop. So it goes through a loop, right? A feedback loop. So, hey, we did not meet the accuracy threshold of 75%.
Right.
So what do we do next? And then we cannot keep business waiting forever. So it has to be reconciled. So that's where the frameworks were quintessential in making that happen. Because
and I think
tools stop at a point. Yeah.
Right. The bridge is not just the framework, but the framework that brings it into the pipeline itself, so that as the data is moving along, the framework isn't in addition to, it becomes part of, right? People are plugged in, it becomes operational, and you've built it in a way that maybe the data engineer doesn't, the analyst and business person is defining the criteria. The data engineer is just inserting in there, and the control of what happens, what decisions to make, really gets back to the business, and they get to trust their data. Great.
Yes. And Joe, if I can quickly take an example of one of the largest systems that or pipelines which we had involving finance and transactions, financial computation and transactions. One of the benefits we got out of, besides, decision making on the go while the pipeline executes, and stop and make sure there's a feedback loop, is the after effect, right? What happens 3 months later, and there's a user who was requesting, hey, my numbers were not right. I was looking at a quarterly report, and the framework was handy, so we were able to go back months in time, right? Like 98 days back. What happened on that particular day? So what were all the data hops? When we had like more than 24 source systems, and they go through hundreds of pipelines, we were able to track the flow or the hops the data or the transaction has gone through, like 3 or 4 months back, and prove that this is where the data flowed through. These are all the points, and we were able to certify at every point in time throughout the pipeline the data was looking good. So we were able to narrow down the problem rather than leaving it up to assumptions, right? It could be the pipeline, it could be the source system,
right.
But besides the auditability, besides the compliance factor, besides the everyday pipeline threshold validations, it really helped narrow down the user and the customer problems months and months later after something has happened, right? So that was a huge benefit.
Right. And that's the end result. The customers, who you're trying to serve in these cases. So being able to come and bring it all the way back, solve their problem, as well as prove that you had the controls in place. This is what happened on this day. I can show you exactly. And now we see exactly why this happened. Yeah.
Exactly.
That's what makes a reliable system, as you mentioned here.
Yeah, exactly. As opposed to taking like 200 gigabytes of logs and looking into them, it's not going to work out. And then I think we have not even got into the AI and the ML world, right?
That's what I wanted to talk a little bit about now. In my mind, there's sort of two avenues that are going on in our world today. One, all the data we produce and generate, how is that going to be used by AI? And then the other half of it is, how can AI help us build, manage, and gain insight from the controls we have in place now? So why don't we tackle the first bullet of saying, okay, if we're producing all this data for AI consumption, are we going to do anything differently to make sure it's reliable for that and suited for that purpose? Is there anything different in the framework from your perspective?
Yeah. So till now, right, we covered the big data transformation, then the cloud transformation, so on. And we thought kind of, hey, we had figured this out, right? We bingo, right? We have a solution, frameworks are yeah. However, the moment AI and ML and then AI came into picture, it made us think through, or is what we do today, are these things we are doing today, they still stay relevant to the AI and the ML world? And what we have figured out so far, because this journey is still ongoing, right? We are still going through the challenges. Every day we have the new methods coming in and approaches coming in, and what we figured out is the foundations still remain the same. We need accuracy, we need completeness, we need freshness, we need accountability. However, the scope had really expanded. Within these areas, it has evolved. So far, it evolved from numbers to null checks, and then data completeness from an attribute and a data asset standpoint. Now you look at a very new paradigm of bias, hallucination, right? How an AI model becomes overconfident, right? I'm tying it back to the Deloitte incident, right? There were citations which were confidently provided by the model, saying that, hey, this is how you need to go, and this is what are my results, right? But how did a model came up with an assumption based approach with high confidence, right? So the platform, or the framework, had to be expanded further. It's the opposite, right? The frameworks did not become irrelevant; it became even more relevant. So today, if you look at some of the pipelines that we have built for AI, for example, I'll take LangChain for example, right? It is now capable of having the same kind of checks that we spoke like a few minutes back. During the pipeline execution, you validate, set up thresholds, look for accuracy, completeness, and then you take a call. Am I going to terminate the pipeline at this point? Go through a feedback loop to fix it. The same applies to AI pipelines as well. So now the frameworks like LangChain have the capability to evaluate a model with sample prompts as the pipeline progresses, right? So it has become, what's different is we have expanded the scope of the framework. That's number one, Joe. Number two is the way we approach the validations, while a pipeline executes, has changed from doing point-in-time checks, to model evaluation, right? Before I expose the model for the day for the users to consume, I validate the agent during the pipeline execution with Trura or LangChain. We do have a bunch of options. I'm glad what happened over the period of last 12 to 18 months. Confidence has really come up when it comes to these pipelines, executing these pipelines. And one of the aspects I definitely want to touch when we're talking about building agents is RAGs, right? Retrieval augmented generation.
Yeah.
And that's where it becomes even more critical for the data to be reliable, because the underlying LLM models have gone through their own scrutinization and validations and so on. But when it comes to a RAG approach, where either it's a cached, CAG, the new term for the cached, RAG approach, or an embedded data set, which is added as a delta on top of the LLM.
Right.
I do not know the data which is the delta which has been added for the RAG to act on today, or it could be any frequency, right? It was added today or the last 1 week, is reliable enough to be handed over to a customer, right? To be exposed to a customer.
Right.
So it becomes even more relevant when it comes to a RAG based deployment, where the embedded systems have to be constantly updated with a cached data set or a delta data set on top of the original or the underlying LLM. So that's where the more contemporary frameworks like
Right.
LangChain or become even more relevant. So frameworks are still that pivotal aspect of the data reliability and the data
Yeah.
consistency, standpoint,
Right.
from a
Right. So
consistency
it's
standpoint.
almost the addition of the AI models, understanding your trust in them, and the data we're feeding, the expansion, and almost because they're
Yeah,
going to read all the data. And I've been reading about attacks on those and how little, how a small amount of bad data fed in can really poison a model, right? So the
yeah,
importance of making sure the data that's under your control that's going to come in is of high trustworthiness, utmost reliability is even more important now than I think before it hit, a Tableau
yeah.
dashboard, right? Now, now the LLM is going to be starting making some decisions on it. Yeah. So,
And then I do have I get the visibility, right? For
mhm.
example, I I operate from 9 to 5. The users are expected to jump in and start using these agents from 9 to 5. At by 6 a.m. in the morning or 5 a.m. The pipelines validate. The frameworks are used to validate these rags with sample prompts and log them with the results for my validation. So before even I hit the road by 9 a.m., I have a baseline of, okay, these are the prompt responses, and I'm having a high confidence today that the delta or the expanded data set which was added kind of makes sense. And one of the more recent implementations which was like really working out for one of the hybrid solutions is there are two parts to the data processing for AI, right? One is the data ingestion, the raw data which comes in from a lot of sources, multiple sources, and there's the AI pipeline itself. It trains the model, and it makes it available for the agents. So a combination of uh, an automated or a tool-based approach. For example, one of the observability tools in the market, right? Acceldata. So there's data reliability component and a pipeline observability component, which makes sure the ingested data conforms to the basic checks or the baseline checks we have in place. And then the extended AI framework, pipeline framework like LangChain comes in, with the certified data, which has been, through the ingestion data validation process, is, of high confidence, is taken up for the next step of the AI pipeline processing. So in this way, I have both the ingested data and the AI pipeline both certified, which gives me a very high confidence when I'm making it available for the business and the users.
Yeah, that's nirvana right there, right?
Yeah.
Well,
Yes.
getting there. So let's spin that for a second. Let's talk about, okay, have you started to sort of aim those AI engines back at your reliable data system to help you make them more reliable, help you find the problem that the customer said, hey, something's wrong, go back 3 months? Have you pointed those AI tools back and become a tool for you to make a more reliable system?
Well, yes, that's still, I would say, in the experimental state, right?
Mm-hmm.
Uh, why experimental is the moment we start addressing customer concerns, right? Entirely, are we in a state where we can entirely give it to an agent and, you figure this out, right?
Mm-hmm.
So, that's where, from an industry standpoint or from an individual team standpoint as well, we are a bit cautious, when it comes to addressing customer concerns. So there is a manual component always included. However, the AI agent, inclusion of AI agents into this, uh, you know, troubleshooting or
Mm-hmm.
mitigating customer concerns has shortened the SLAs by a lot. So, for example, one of the scenarios or the challenges which popped up was, we had a performance bottleneck. And if you look at traditionally, if an ETL pipeline going through a performance bottleneck and a customer getting back to you on, yeah, I'm not able to, get the data on time, a manual validation, which kind of takes us hours and hours of digging through logs, and also the data. Right, there's a data reliability component as well as a technology component to evaluate the logs. How this data travels through the pipelines. So that was made really simple when you bring in an AI agent doing it for you.
Right.
So they, irrespective of what format the logs are and what the constraints are. But getting back to my initial response, Joe, we still vet it manually so that we are not entirely leaving it to the AI to determine, where the bottleneck is.
Yeah.
So the short answer is yes, we do leverage the AI agents to go back and check what happened within the pipeline. But again, there is a manual validation which happens on top of it, because we like full self-driving, right? We are not quite there yet.
We always talk at Acceldata about starting with human in the loop, right? Let the AI agent do the work. You can view, direct, approve, decide to adopt or not. When the trust is built, we can put the human on top of the loop, supervise it, maybe give the agent some more autonomy to do more things, but still have a view. I don't know that I ever want agent have the human out of the loop. I don't like the term out of the loop, so maybe over the loop.
Yes.
Yeah, right. I spent some time out of the loop. So anyway.
And then very quickly to that point, right? One of the more recent, releases that we experience with Acceldata as well is, there are DBT cloud or the pipeline observability also ties it back to data reliability, right? Pipeline runs, and then I'm able to automatically see the associated data assets have been checked for data reliability. So that kind of brings our timeline down from like hours and hours to a few minutes. Hey, this is already out there. And then that's where framework with automated observability and data reliability tools with extended frameworks to go through AI makes things, they still stay relevant and make things easier.
Yeah, I always think of it as the observability platforms like ours bring together a lot of signals, like from your DBT cloud, from your data quality checks, et cetera. And that for some of our clients took RCA down from like 2 weeks to 2 hours. But now these agents have access to all that data and may take it down to 5 minutes, right?
Yes.
So that your SLA can get with more insight, right? So all good stuff. One last question, because I've held you longer than I meant to, but I appreciate your time. So what do you see as the biggest challenge on the horizon dealing with this new wave of change that AI is ushering in? Is it expectations for that? Is it just the hard realities of the work to be done? What's your biggest challenge over the next 12 months?
I would say the immediate challenge is keeping pace with enhancements to not just the tool set, but also to the methodologies, and with increasing emphasis on security, data security, and the compliance and guidelines. So that has been the challenge, right? Two main challenges. One is keeping up with the pace of the technology and the methodology changes, and the number two is the security, because the agents and data, right? It becomes really effective when we have access to the data,
right?
And access to the data also opens up security concerns to, there could be penetration, there could be hacks, and so on. So that is really a big challenge, where the teams or the technology folks cannot do everything we want to do be it experimentation, be it implementation, we do not get the same access to data as we used to with increased focus on security. And of course, the technology changes rapidly. And more recently, we are looking at multi-models, right? 3D models, and so on. And then the agents becoming capable of deciphering not just texts and texts of documents, but also videos, photographs, and so on. So the technology aspects keeping pace, and the security challenges when it comes to securing your data. I need access to the data, and also I need to secure the data.
Right.
So
you got to be paranoid, and I have to be open at the same time. Right.
So that I would definitely say a bigger challenge. One of my friends, who have spent like more than 2 decades in the data space. We had this discussion last weekend where we wanted to experiment a bunch of ideas we had. But again, getting access to such data sets and experimenting it has to go through the security constraints and checks and balances as well. So that kind of slows down, how much you want to accomplish, and then also it by the time you try to do that, something else has happened. Folks have moved from the third mile to the fourth mile, and it becomes irrelevant. So that's a major challenge.
Yeah. Keeping pace is a tough one, but. Okay. Hey, I want to thank you for your time and insight today. I really appreciate. I hope you enjoyed the conversation. I certainly did. For our viewers, I want to thank you for tuning into Data Forward, and I hope you'll be tuning into our next episode. And one more time, Jay, thank you very much. I appreciate your time today.
Thank you.
Welcome to Data Forward, the podcast that keeps you ahead in the fast-evolving world of enterprise AI and data management. We bring you expert insights, actionable strategies, and the latest trends to help you stay on top. Ready to shape the future of data? Let's Data Forward.